Welcome everyone. In this video, I am going to talk about normal distribution and its properties, and I will also solve few interesting problems related to normal distribution. In the next video, I will be talking about normal approximation of binomial distribution and moment generating function of normal distribution. So for normal distribution, there will be two videos that will cover the content. So let's start. First of all, normal distribution is a continuous probability distribution. We have seen in my earlier videos like binomial distribution, negative binomial distribution, Poisson distribution, or other kinds of distribution. Those were examples, or those were categories of discrete probability distribution. But normal distribution is a continuous probability distribution, and you know that for a continuous probability distribution what we need is a probability density function. So if I look at this, a random variable x is said to have a normal distribution with parameter, and for normal distribution mu and sigma square, which is variance, are known as its parameter, if its probability density function is given by the probability law. So this is the probability density function, and you need to remember this because this is the important term. So 1 by sigma under root 2 pi e to the power minus 1 by 2 sigma square into x minus mu whole square. Here this x can take the value between minus infinity to infinity. The mu, that is the mean or expectation of the random variable x, can take the value between minus infinity to infinity, and sigma will be greater than 0. Now let us look at some of the very important properties. The first remark that I want to make, that a random variable x with mean mu and variance sigma square and following the normal law is expressed as x follows the normal distribution with mean mu and variance sigma square. So suppose I write something like x follows the normal distribution with mean 30 and variance suppose I say 16, right? So here what is the mean? Mean will be considered to be 30 and variance like sigma square is considered to be 16. So this is how we represent that x is following the normal distribution with these two parameters. Second important thing is that if x follows the normal distribution with parameter mu and sigma square, we can define something known as a standard normal variate, and this is the most important thing because our focus will be more on this variable. So a standard normal variate z is defined as x minus mu by sigma, right? And expectation of z in this case will be equal to 0 and variance of z is equal to 1. So this is actually a standardization of the normal distribution, and that is why we call it that z follows the standard normal distribution with mean 0 and variance 1. So you will notice that in most of the problem, while solving the problem, first we change the normal variate into a standard normal variate, and then we look for the possible solution. Now another important thing, that if I talk about probability distribution in case of a standard normal variate, so the PDF probability density function of a standard normal variate is given by phi z, and it becomes 1 by under root 2 pi because sigma becomes 1. Here if you see that if z follows the normal distribution with mean mu, mean 0 and variance 1, so here the sigma will become 1, and here this mu is 0, so it will be just 1 by 2, and in actually let me write it, otherwise you may be confused. If you look at this expression, what is this expression? This expression is 1 by sigma under root 2 pi, right, and e to the power minus 1 by 2, and this can also be written as x minus mu by sigma whole square. Yes or no? Now it can be replaced because sigma is equal to 1, so it will become 1 by under root 2 pi and e to the power minus 1 by 2, and this is what we are defining as a standard normal variate, that is x minus mu by sigma. So this becomes z square. So in case of a standard normal variate, we have this probability density function, and here this standard normal variate can take the value between minus infinity to infinity. Okay, so I hope up to this there is no doubt. Moving forward, the normal distribution curve look like this. So basically, if you draw the graph of this function, I hope you all know when I talk about the graph of this function. So if you draw the graph of this function, the graph looks like this. This is a bell-shaped curve, and this is a symmetrical curve about the line x is equal to mu. So you see that it is symmetrical about this line, and this is the line x is equal to mu, and in terms of z, this will be actually what? This will be 0, because how the z is defined? Z is defined as x minus mu by sigma. So if you take x is equal to mu, the z will be equal to 0, right? Now there are certain characteristic of this curve. So first of all, I hope it is clear to you that this is the graph of the probability density function x, mu and sigma square, right? And the graph actually as you can see in the previous slide also, that x can take value between minus infinity to infinity. So this graph actually goes up to minus infinity in this direction, and this graph also goes up to plus infinity in this direction. But another important observation is that if you look at this graph, there is one more thing that we have studied in continuous probability distribution, that if we integrate our continuous probability distribution, like if we integrate our PDF, in this case if I integrate f of x mu sigma square dx, right, from minus infinity to infinity, or I can write minus infinity to infinity 1 by sigma under root 2 pi e to the power minus 1 by 2 sigma square x minus mu square dx, then this will be equal to 1. The total probability is equal to 1, and this is one of the characteristic of probability density function. Some of the students who might be interested, you should also try to prove this. I would leave this as an exercise for you and try to prove it in case if you are interested, but here we are assuming that this can be proved to be equal to 1. So the first characteristic is that if you take the area under the normal distribution curve, this is equal to unity. This is equal to unity because total probability, and the probability in case of continuous probability distribution, how do you calculate? If you remember, earlier we have discussed that in case of continuous probability distribution, we calculate the probability for an interval. So here if I take the random variable x in the interval alpha to beta, what we have to do? We have to integrate the probability density function. Suppose I say in this case f of x mu sigma square between the point alpha and beta. But fortunately we don't have to do this because this is a very important distribution, and we already have an alternate method that I am going to discuss in the this video itself. So be to the very end of this video, means watch this video till the very end, so you are clear about the concept. Now another important observation that I want to make, that if you take the interval, this is the line x is equal to mu, right? And if you take this interval mu plus sigma and mu minus sigma, so in this interval 68.26% area lies under this curve. So the probability that random variable x will take the value between mu minus sigma to mu plus sigma, right, that probability is 68.26%, or 68.26 is the percentage in terms of probability. You can consider it is 0.68, right? Similarly, if I take the interval mu minus 2 sigma to mu plus 2 sigma, 94.44% of the area lies under this curve. And in the interval mu minus 3 sigma to mu plus 3 sigma, total area that is lying under this curve is 99.72%. So basically what is the conclusion from this argument that I am trying to make? The conclusion is that it is very unlikely that random variable will take a value which will go beyond mu plus 3 sigma and also go beyond mu minus 3 sigma, because most of the random variable value will lie between the interval mu minus 3 sigma to mu plus 3 sigma, and that probability is almost equal to 1. It is 99.72% area, means it is almost close to the total area, that is equal to 1. So now I have listed the properties in a systematic way, because some of the properties while highlighting this I might have missed. So keep these properties in mind. These are very important properties, especially for solving multiple choice question. So the first property is that the curve is bell shaped. As you can clearly see that this curve is like a ghanta or bell shaped, and symmetrical about the line x is equal to mu. So that line is x is equal to mu that I highlighted, and you can also say that it is symmetrical about the standard normal variate, that is z is equal to 0. This is a very important property, and interested students should try to prove this also, that mean, median and mode of the distribution coincide. So this is a very important property. Sometimes they ask that for which of the probability distribution the mean, median and mode all are same. So for that it is normal distribution, because it is a very symmetrical distribution. Third important characteristic is that as x increases numerically, fx decreases rapidly, and the maximum probability occurring at point x is equal to mu and is given by 1 by sigma under root 2 pi. So what it is basically suggesting, that you see that this table gives you the probability. So at this point, when the probability is maximum, the probability is maximum at x is equal to mu. This is the maximum value, and as you take x in the increase the value of x, the probability decreases very sharply, right? You can see that there is a very sharp decrease, and at x is equal to mu, what is the probability? So at x is equal to mu, if you take this x is equal to mu, what you will get here, this will become 0, right? This term will become 0, because mu minus mu will become 0. So e to the power 0 is equal to 1, so you will get 1 by sigma under root 2 pi. So this is what they are suggesting, that the maximum probability that random variable can take is equal to 1 by sigma under root 2 pi. Next property is, since fx being the probability can never be negative, we know that this is one of the property that we have studied for continuous probability distribution, that f of x is greater than or equal to 0, and if I integrate f of x from minus infinity to infinity, that is equal to 1. So that we already know. So that is why, since fx being the probability can never be negative, so no portion of the curve lies below the x-axis. So that is also very obvious that everything is lying above the x-axis, because probability is always positive. Another property is that linear combination of independent normal variate is also a normal variate. So what they are suggesting, that suppose I say x1 is a normal variate, x2 is a normal variate, then if I take alpha x1 plus beta x2, so that will also be a normal variate if these two normal variates are independent. The next property is that x-axis is an asymptote to the normal distribution curve. So if you consider this axis as x-axis, right, and this axis as y-axis, you can see that x-axis almost become like a tangent to the normal distribution curve at for a very large value of x, right, almost at infinity. So this curve, like this x-axis, becomes almost a tangent. So this curve is known as an asymptote to the normal distribution curve. So here x-axis is the asymptote to the normal distribution curve. So this is a very important property, and this I told you to prove that area under the normal distribution curve is unity. Okay, so these are few important properties. Moving forward, this is the most important part of the whole discussion, that how to check the value of probability in the normal distribution curve, and I will be very slow here. So basically, in most of the books they provide two kind of table. Some books provide this table, I will explain why we need this table, and some book provide this table. So I will talk about both of them one by one, and to make sense of it, why this table is needed, I need to solve the problem, right? Otherwise you will not be able to make sense of it, right? And I will solve the problem with the help of both these tables. In exams, usually they do not provide the table, they will provide you the value, the standard values, but you need to judge that how to use that value. That is the main learning that you have to derive. So to make sense of it, let us take this a small question. That a small question is that let x is normally distributed with mean of x 12 and a standard deviation is 4. Find out the probability for the following. What is the probability that random variable x will take value greater than or equal to 20? What is the probability that random variable will take the value less than or equal to 20? And what is the probability that random variable x will take the value between 0 and 12? Okay. So basically, whenever we have to solve this problem, those who have clear understanding of continuous probability distribution, they will say that, sir, if I have to calculate the probability for x greater than or equal to 20, I will integrate from 20 to infinity, because in case of normal distribution, the x takes the value between minus infinity to infinity. See, this is plus infinity, sorry, minus infinity to infinity. And then we will integrate f of x mu sigma square dx. But this is not something that we are going to do, because they have made our life easier by already doing some computation and have created a normal distribution table. So if we are not going to do this, what we are going to do? So whenever we have to solve something like, first of all, let me list the thing that they have provided in the problem. It is given that let x is normally distributed. They already have highlighted this with mean of x is 12. It means the mean of the normal distribution mu is equal to 12, and a standard deviation is 4. A standard deviation means sigma is equal to 4. So first part is we have to find the probability for x greater than or equal to 20. So whenever we have to find the probability, first of all, if I take x is equal to 20, we have to calculate the standard normal variate z corresponding to x is equal to 20. And how the z is defined, I already have defined it, that is x minus mu by sigma. So what is x here? That is 20. So I will take 20. What is mu here? That is 12. And what is sigma here? That is equal to 4. So 20 minus 12 by 4, that is equal to 3. So if I have to calculate the probability for x greater than or equal to 20, actually I have to calculate the probability for z greater than or equal to 3. This is what we have to calculate. I think I made already a mistake. I don't know why. Have you noted it? It is not 3. 20 minus 12 by 4 is 8 by 4. So basically it should be 2. I don't know why I make this mistake, because it is not the first time. I might have made this kind of mistakes earlier also. But as you know, to err is human and to forgive is divine. So please forgive me. You are all divine people, yeah? So we have to calculate the probability for z greater than or equal to 2. Now how to calculate the probability for z greater than or equal to 2? And this is very important, so listen it very, very carefully. First of all, if you I draw the normal distribution curve. I will be drawing a picture. It may not look very symmetrical, but I hope you will allow me to use this. So this is the normal distribution curve, and as you have seen earlier that I was calling it that it is corresponding to z is equal to 0 or x is equal to mu, right? So I am talking in terms of z, so I am considering it z is equal to 0. So if z is equal to 0 is here, z is equal to 2 will be somewhere around here. So basically, if I have to calculate the probability for z greater than or equal to 2, I have to find the area under the normal distribution curve which is lying in this side, because the area under the normal distribution curve gives me the probability, and we also know that total probability is equal to 1, right? If I calculate the area from minus infinity to infinity. Now the table comes into the picture. So now let us look at two tables. Let us look at this table first. So if you look at this table here, this table gives you the area between 0 to z. Sorry, this table gives you the area between 0 to z. Why? Because we know that if the curve is symmetrical, 50% of the area, means half of the area, will lie in the left of z is equal to 0. So this area we already know is 50% area, and 50% of the area lies in the right of z is equal to 0. Why? Because the curve is symmetrical, right? So half of the probability, means total probability from 0 to infinity, is equal to if I ask you what is the probability for 0 less than z less than infinity, so that will be equal to 1 by 2. And if I ask you what is the probability for minus infinity less than z less than 0, so that will also be equal to 1 by 2, right? Because total probability is 1. Now if they are giving me this, so what is this value? First of all, if I have to look at the table, so where is z is equal to 2? This column you can see we are starting from z is equal to 0.0 to going up to 3.4. One more thing I wanted you to note, that Z will take value greater than 3.4. It is very, very unlikely, because up to Z is equal to 3.4, you can see this value. I am writing it for your convenience. It is 0.4998, means 50%, out of 50%, 49.98% of the area lies up to 3.4. Now if you look at this curve, for Z is equal to 2, so where Z is equal to 2, this point is Z is equal to 2, and I am highlighting this is the value 0.4772. So basically what is given in this problem, I am using another color so that you don't get confused. They have given us this area. This area is how much? This area is, look at the table again, it is 0.4772, 0.4772, right? So 0.4772. So if I have to calculate the probability for Z greater than or equal to 0, what we can do? We can take the total probability, that is in the right of Z is equal to 0. What is the total probability? That is 0.5, and minus, I have to subtract this region which is lying between 0 to Z, because I have to calculate the probability in the right of Z. So I will calculate probability 0 less than or equal to Z and equal to 2. See, I hope you remember that in case of continuous probability distribution, probability at a point is equal to 0. So don't be very fussy about that here I am writing greater than or equal to, or here I am writing less than or equal to, because at a point the probability is 0. For continuous random variable, the probability is always in the interval. So what I will calculate? I will calculate 0.5 minus 0.4772. So this value will be actually 0.0228. So the probability that x will take the value greater than or equal to 20 is equal to 0.0228. Now I personally prefer to use this table, but I also want you to see the picture through the other table. So if you look at this table, and I wanted to calculate the probability for Z greater than or equal to 2. So this table gives me the area, total area in the left of Z. So if you look at this value, Z is equal to 2 here, and what is the total area that is they are providing? They are providing the value 0.9772. 0.9772. So basically, did you note in this part, in this figure, they were giving me this let me look at this table. This was given to be 0.4772 for Z is equal to 2, and if you look at this table, it is given to be 0.9772. So basically, why it is so? Because we already know that up to Z is equal to 0, this area is 0.5. So the other table is giving me the area between 0 to Z, but this table is giving me the area in the left of Z. So what they are basically giving? They are giving the area from minus infinity less than equal to Z, or you can remove the equal sign, because some of you will say that we can never reach the infinity. So I should remove it. Right. So minus infinity less than Z and less than or equal to 2. So that area here is given to be 0.9772. So in this case, if I have to calculate the probability for Z greater than or equal to 2, what we have to do? We know that total area, actually we have to calculate the area in the right of Z greater than 2. So I can take 1 minus probability for Z less than or equal to 2. So that will be 1 minus 0.9772. So I will get the same answer, that is 0.0228. So now, whether you have to use this table or that table, there is no confusion in this, because it is just this table gives you the total area in the left of Z, but this table gives you the area from 0 to Z. So whichever value is provided in the exam, or whichever table is available to you, you can use it if you know the symmetry of the normal distribution curve. I hope up to this there is no confusion. Now moving ahead, I want to calculate the probability for Z for x greater than less than or equal to 20. So probability for x less than or equal to 20 is what? It is 1 minus probability for x greater than or equal to 20, because I already have calculated this probability. Why should I put the effort again? So that will be 1 minus 0.0228. So that will be equal to 0.9722. And if you remember, this was the same value that I was getting here, 0.9772. That is the total area in the left of z is equal to 2. Okay, so I hope by now you are clear about this idea that how to calculate the probability. I am going to solve the third part. So I am going to move to move to the next page, because we don't have the space here. So in the next page I am going to calculate the probability of x taking the value between 0 to 12. So we have to calculate probability 0 less than or equal to x and less than or equal to 12. So we have the mu value that is equal to 20. Let me see whether it is a mu value is 20. No, mu value is 12 and sigma value is 4. So mu value is not 20, mu value is 12 and sigma value is 4. So to calculate the probability for x taking the value between 0 and 12, first of all, I will calculate for x is equal to 0, what will be the standard normal variate z, that is x minus mu by sigma. So here it is 0 minus mu is 12 and sigma is 4. So what I get is minus 3. And then I calculate for x is equal to 12. So z is equal to again x minus mu by sigma. So that I will get how much? That I will get 12 minus 12 by 4, that is equal to 0. So if I have to calculate the probability for x lying between 0 and 12, I have to also calculate the same probability will be when z is lying between minus 3 to 0. Right. Now you may say that if I draw the normal distribution curve for your convenience one more time. So if I draw the normal distribution curve, basically which region we have to calculate. This is z is equal to 0, and suppose I say this is minus 3 and this is plus 3. So we have to calculate the area from minus 3 to 0. And you know from the symmetry that the area between minus 3 to 0 will be equal to the area between 0 to 3. Right, and so I can write it that this is nothing but the area between 0 to 3. Why? Because the curve is symmetrical, and if I have to use this table here, you can see that up to 3 the area is 0.4987. So this 0.4987, this value that they are providing, is the area from 0 to 3. So what will be the answer for this? The answer for this will be 0.4987. Now just for your argument, if you ask me that, sir, how I will calculate the value in case this value is given, this table is given, right? So I will let you think about this and calculate the value using this table also, but I personally prefer this table. But because you know what is the argument, so you might have understood it. Okay, let us quickly solve few more problem, and this time I will not be using both the table, I will be just using one of the table. So how to solve this kind of problem? Let x is normally distributed with mean. So x is normally distributed, mean of x is 30. So it means mu is equal to 30. A standard deviation sigma is equal to 5. First question is that x should lie between 26 to 40. So first I calculate if x is equal to 26, what is z? We also a standard normal variate value, that is x minus mu by sigma, that is equal to 26 minus 30 by sigma, that is equal to 5, that is minus 0.8. And if I take x is equal to 40, then what will be z? Ladies and gentlemen, z will be I should write directly, it will be 40 minus 30 by 5, so that is equal to 2. So basically we have to calculate the probability for z, that is for 26 it is minus 0.8 and z, and for 2. So if I just draw the normal distribution graph so that you understand it better. This is the normal distribution curve, right? And which area I have to calculate? I have to calculate the area. Suppose I say this point is minus 0.8 and this point is z is equal to 2. So I have to calculate the total area under the normal distribution curve. So sorry. So how to calculate that? If I want to use this table, they are giving me the area in the right of 0. So here we have to use the symmetry, and listen this very carefully. If I have to calculate this area, I hope you will allow me to calculate this area by taking this area, finding the area under this from minus 0.8 to 0, and then finding the area from 0 to 2. So I can write it, this is equal to probability minus 0.8 less than or equal to z less than or equal to 0, and plus probability 0 less than or equal to z and less than or equal to 2. Now this area we can look from the table, but to look for this area, what we have to do, we can use the symmetry, because area from minus 0.8 to 0 will be also equal to area from 0 to 0.8, because the curve is symmetrical. So this area will be nothing but 0 to 0.8, right, and plus probability 0 less than or equal to z less than or equal to 2. So for 0 to 0.8, if I look at the area, what is the value for 0.8? It is 0.2881. I hope you can see it. It is 0.2881. So I am writing 0.2881, and plus from for 0 to 2, you can see the area is 0.4772. So that is 0.4772. So if you calculate this value, that will give you 0.7653. Now the question is, what if I have the other table available? So how I'll calculate that area? So to answer that, I am not only answering, this video will become longer because I want to make you clear about different aspects of it, because solution I already have obtained, but depending upon what kind of scenario you may face in the exam or in any situation, you should be clear about both. So I have to calculate the area between minus 0.8, this is minus 0.8 to 2, right, and the table that is available here is this. So in this case, let me for your convenience make a space here and calculate the things from this table, right. So what we can do, we have to calculate the area between minus 0.82. So I'm writing here so that we don't have to scroll again and again. So we have to calculate the area between minus 0.8 less than or equal to z and less than or equal to 2. So up to 2, the total value is 0.9772, right, up to 2, right. And what I can do, I can write that this is the point, suppose I say is minus 0.8, and this point, suppose I say z is equal to 2. So what I can do, I can subtract the total area up to z is equal to 2, means I can write probability for z less than or equal to 2, right, and minus, listen this carefully, this area, means this is the total area up to z is equal to 2, means in the left of z is equal to 2, and in the left of z is equal to minus 0.8. So I will write probability for z less than minus 0.8. But for minus, they have not provided us the value, that what is the area in the left of minus 0.8, right, but they certainly have provided us the value for area in the left of 0.8. So area in the left of minus 0.8 is how much? That is equal to the total area. I hope you are getting it. So we have to calculate probability z less than or equal to minus 0.8. So from the symmetry we can say that this is nothing but the probability for z greater than or equal to 0.8. I hope you agree. If you look at this curve, what is lying in the left of minus 0.8, it will be the same thing in the right of 0.8, because everything is symmetrical. And this can also be written as so now we already have the value of probability for z less than or equal to 2, that is 0.9772, and minus. How to calculate this probability? This probability, because I am using this table, should be calculated as 1 minus probability for z less than or equal to 0.8, right. So this is equal to 0.977 and minus 1 minus, and up to 0.8, what is the probability? That is 0.7881. So 0.7881. So if you do the calculation, you will get the required value, and that value will be similar to the value that we have already calculated. Okay, so this is how you can use both kind of tables. Now suppose I have to calculate the next part of the problem, that what is the probability of x greater than or equal to 45. So I am not going to move to the next page. I am using this as space because moving next page will create problem. So I have to calculate the probability for x greater than or equal to 45. So if x is equal to 45, what is z? Z is equal to x minus mu by sigma. So what is x? X is 45. What is mu? Mu is 30. And what is sigma? Sigma is 5. So what we get is 45 minus 30 by 5, that is equal to 3. So we have to calculate basically probability for z greater than or equal to 3. And if I am using this table, probability for z greater than or equal to 3 means for the normal distribution curve, if I look at this curve and I say z, this is z is equal to 3, so I have to calculate the probability for z greater than 3. So from 0.5 I can subtract probability for 0 less than z less than or equal to 3, because the total area in the right of 0, so I can write it, this is equal to 0.5 minus probability for 0 less than or equal to z less than or equal to 3. Okay, and that will give me 0.5 minus, and for 0 to 3, what is the value? For 3 you can see it is 0.4987. So I am writing minus 0.4987. So this is very small probability, that is 0.0013. Next part that we have to calculate probability for mod of x minus 30 greater than 5. This is what we have to calculate probability, right? So to calculate this probability, first of all, I hope you remember the mod property. So if I am saying mod of x minus 30 is greater than 5, it implies two things. There are two parts of it. First is x minus 30 is greater than 5. This is the first part. So this implies that x should be greater than 35. And this also implies, means both of them come together, that minus of x minus 30 should also be greater than 5. So if I look at this, it will give me minus x plus 30 should be greater than 5. So this will imply what? This will imply minus x should be greater than, I take 30 in the right hand side, that is minus 25. So basically this can be seen as x should be less than 25. I multiplied minus in both sides, so the sign of inequality will change. So this expression is basically equivalent to what? If I have to calculate the probability of mod of x minus 30 greater than 5, this is equal to the probability for x greater than 35, because in this case also this will be satisfied, and plus probability for x less than 25. Now if x is equal to 35, what is equal to z? So z is equal to x, that is 35, minus mu. So mu in our case, what was mu? Mu was 30 and sigma was 5. So mu was 30, 35 minus 30 by 5. So that is equal to, z is equal to 1. And for x is equal to, if I draw this here, 25, what is z? So z is equal to 25 minus 30 by 5, that is equal to minus 1. So this probability, let me change the color. So I will be calculating, this is equal to probability for x greater than 35 is equivalent to z greater than 1, and x less than 25, this corresponds to z less than minus 1. So if I look at the normal distribution graph, and I hope by now you are very clear about this, I have to calculate the probability. If I take this is z is equal to 1, and if I take this is z is equal to minus 1, so I have to calculate the probability in the right of z is equal to 1, means this area, and in the left of z is equal to minus 1, means this area, this is minus 1. So for this, for z less than or equal to minus 1, what I can write? I can write probability for z greater than 1, and because of symmetry, ladies and gentlemen, probability for z less than -1 means this area will be equal to nothing but probability for z greater than or equal to 1. So basically this is 2 times probability z greater than 1, right? Now how to calculate probability z greater than 1? It can be calculated at 0.5. Now I have to calculate this probability. So how can I calculate this probability? Total area in the right of z is equal to 0 is 0.5. So 0.5 minus probability 0 less than z less than 1, right? And this value I can look for table. So for z is equal to 1, where is the table? I am going to look at the table. For z is equal to 1, the table value is 0.3413. So I suggest you that keep the table handy. So this is equal to 2 times 0.5 minus 0.3413. So if you do this calculation, because we don't have the space here, I am writing it, it is equal to how much? It will be equal to 0.3174. 0.3174. So that is the required probability. So I believe up to now there is no challenge. All the questions you have understood. Now I'm going to solve some real world problem so that you understand it better. So we have 4 questions, and let me see that how much time does it take to solve the remaining 4 questions. Okay. So a certain type of storage battery lasts on average 3 years. On average means mean, mu is equal to 3.0, with a standard deviation of 0.5 year, means sigma is equal to 0.5. Assuming that the battery life is normally distributed, find the probability that a given battery will last less than 2.3 years. Means they are saying that if this is normally distributed, what is the probability that x will be less than or equal to, because I hope you are clear that if I write this or if I write this, it should not make much difference in terms of probability, because in case of continuous distribution the probability is actually at a point is equal to 0. So if you want to calculate less than 2.3, so since it is saying less than, I prefer writing probability for x less than 2.3. So first of all, I hope you remember what we have to do. We have to calculate for x is equal to 2.3. I will calculate z. Z is equal to x, that is 2.3, minus mu, that is 3.0, by sigma, that is 0.5. So it will become how much? It will become 0.3. 2.3 minus 3, that will be 0.7, and then it will be multiplied by 1 by 2, so it will be minus 1.4, right? So we have to calculate probability for z less than minus 1.4. okay. So again, the normal distribution curve, always keep in the mind, in case if you are in trouble, it is always better to draw it. So suppose I say this is z is equal to 1.4, and I say this is z is equal to minus 1.4. So which area we have to calculate? We have to calculate the area in the left of minus 1.4, means this area. And from the symmetry we know that area in the left of minus 1.4 is equal to area in the right of 1.4. So I can write this is equal to probability for z greater than 1.4. And if I have to calculate this area greater than 1.4, so I will take the total area in the right of z is equal to 0, that is 0.5. right? So I will write this is equal to 0.5 minus probability for 0 less than z less than 1.4, sorry. And for this we have to look into the table. So I'm not going to look into the table, I'm writing it directly, but I would suggest you that look at the table carefully. And if you look at the table for 1.4, or let me show you the table, because point terms is coming for the first time. So if I look at 1.4, how do I look at the table for 1.4? It is already given 1.4, and that is given to be 0.4192, right? You can see. So I will write it, this value is 0.4192, where I am, yeah, here. So I'm writing it 0.4192. So this probability is equal to, if you calculate, it will be 0.0808, right? So this is the probability in case probability is less than z is less than minus 1.4. So this kind of problems I hope you will be able to solve. Let us look at the next problem. An electrical firm manufactures a light bulb that have a life before burnout that is normally distributed. They highlighted this with mean equal to 800. So I write mean is equal to 800 and a standard deviation of 40 hours. A standard deviation of 40 hours. Find the probability that a bulb burns between 778 to 834 hours. So means they are actually expecting us to calculate the probability that x takes the value less than 834 hours but greater than 778 hours, right? So this value I have to calculate. So if x is equal to 778, what is z? So z is equal to x minus mu by sigma. So that is 778 minus 800 divided by sigma, that is equal to 40. So if you do this calculation, you will be getting minus 0.55. Right, and if x is equal to 834, what will be z? Z will be 834 minus 800 divided by 40. So that will be equal to 0.85. So we have to calculate the probability in the region minus 0. For 778 minus 0.55 less than z less than 0.85. So basically if you look at the normal distribution curve, for your convenience I am drawing it again, and it is always better to draw it so that there is no scope of confusion. So you see what they are suggesting, that suppose I say this is 0.85 positive value of z, and this is suppose I say minus 0.55. So we have to calculate this area, means area under this. So that will be what? That will be the total area from 0.0 to this is value 0. So this area and plus this area. So to calculate this area, I will use the symmetry. So I am writing it. It is probability for minus 0.55 less than z less than 0 plus probability for 0 less than z less than 0.85. And this I can calculate from the table. And for this I can use the symmetry. The area between minus 0.55 to 0 is same as area between 0 to 0.55. So I can write that this is 0 less than z less than 0.55, and this is plus probability 0 less than z less than 0.85. Now let us go and look into the table 0.55 and 0.85. So how to look into the table? I am using this table 0.55. So this is 0.5. This will give me 0.5, this will give me 0.51, this will give me 0.52, this will give me 0.53, 0.54, 0.55. So that is 0.2088. And what is the 0.85 value? 0.85 value is 0. You can see how much is the value 0.85. This is 0.8, 0.85 is this value, right? Is no this value. So 0.3023. Okay, so if I write this total 0.2088 and 0.3023, so I will get the total probability. So let me write it over here. So this value is 0.2088 plus 0.3023. So that I will get is 0.5111. So that is the required probability in this case. Okay. Okay, next question. In an industrial process, the diameter of ball bearing is an important measurement. The buyer set a specification for the diameter to be this. Right. So buyer is saying that if you are creating something, its diameter should lie between 3.0 plus minus 0.11. Basically means between 2.99 to 3.01. That is what they are expecting. The implication is that no part falling outside this specification will be accepted. So if you are manufacturing something, the buyer will not buy it if your diameter is not falling in this interval. It is known that in the process the diameter of a ball bearing has a normal distribution with mean it is given and a standard deviation it is given. On average, how many manufactured ball bearings will be scrapped? So I think I should not take much time, and you are also mature enough to answer it, that we have to calculate the probability that what is the value that x takes the value between 2.99 to 3.01, right? Their question is how many scrapped ball bearing will be scrapped, means how many will be like of no use. So if it lies between this specification, means from 2.99 to 3.01, it will be accepted, otherwise it will be rejected. So if I have to calculate this probability, suppose I take x is equal to 2.99, what will be z? Z will be equal to 2.99 minus mu, that is equal to 3 by sigma, that is 0.005. And if you do this calculation, basically you will get that is equal to -2. And if you take x is equal to 3.01, z will be equal to what? It will be 3.01 minus 3 by 0.005. So it is like again 2. I hope you know how to do the calculation. Now this probability, actually I have to calculate that what is the value, what is the probability that z will lie between -2 to 2, right? -2 to 2. So to calculate the probability between -2 to 2, again we can use the symmetry of the curve, that if this is 2 and this is -2, so we have to calculate this total area. So I can calculate this is 2 times the area between 0 to z, because the table gives me the area from 0 to z, and this is 2 times, if you calculate the area from 0 to z, it is 0.4772. I remember this because I already have used this in the calculation. You don't have to remember, they will provide in the exam, either they will provide you the table or they will provide you this value. If they are not providing, then you will not be able to solve it. So it is 0.9544. So the probability that z will take the value between -2 and 2 is 0.9544. So in what case, how many items on average will be scrapped or rejected? So if I calculate the rejected probability, probability of scrapped or rejected, probability of rejected ball bearing, that is equal to 1 minus, this is the acceptance region, that is 0.9544. So this is equal to 0.040456, right? So basically if you convert it to the percentage, it will be like equal to, this will be equal to 4.56%. So as a manufacturer, this much of item that you are producing will be rejected by the buyer, because this percentage of item will not meet the specification that is required by the buyer. Okay. So let us do one more problem. Problem solving makes the man perfect, and I hope you are enjoying the video. It is very important for you to share it with all your friends, so that they also get benefit from this. But anyway, look at this next question. Gauges are used to reject all components for which a certain dimension is not within the specification. 1.50 plus minus d. It is known that this measurement is normally distributed, so it is given mu is equal to 1.50, mean is 1.50, and a standard deviation, that is sigma, is equal to 0.2. See, if they give you variance, then the variance is sigma square, so in that case you have to take the square root of it. So read the question carefully. Don't just jump to the calculation, conclusion that this is sigma. It may be variance also. So in that case, you have to take the square root of it. Determine the value of d such that the specification cover 95% of the measurement. Right. So basically, what is our expectation? They are asking that for what value, if I take this 95%, will be covered, right? Determine the value d such that a specification cover 95% of the measurement. So means I have to calculate the probability that 1.50 minus d less than x less than 1.50 plus d, and this value, this probability should actually be equal to 95%, means this probability should be equal to 0.95. I hope you are getting it. There are some very scientific term that they are using, but basically what they want is that we have to find that value of d such that a specification cover 95% of this measurement, right? So if I have to calculate, now there is a kind of reverse thing. They already have given us the probability. Now they're asking you to find the interval. But one thing I want you to remember here, and this is a standard thing. This is basically a standard thing. I don't know whether it is given in the normal distribution graph that I have drawn. It is 94.55 mu minus 2 sigma to mu plus 2 sigma. Basically, it is a standard term that you need to remember, that for a normal distribution graph, this you have to remember, this is a standard thing. For a normal distribution graph, 1.96, if you take the value of 1.96 and minus 1.96, and in testing of hypothesis that you will be studying later, you will be using this. Between 1.96 to 1.96, 95% of the area lies under this. So it means what? It means that it is already given that 1.96 should be equal to one of the values, right? Basically, let me write one more step, otherwise you will get confused. Just give me a moment, because it is also important for you to understand. So I am writing, this implies probability 1.50 minus d less than x less than 1.50 plus d. And this probability, actually, if I write like this so that we can compare, this is z. If I compare it in terms of x, so this 0.95 probability is minus 1.96 less than z less than 1.96. I'm talking about z. So this value of x should be equal to this value of z. That is what I am saying. So it means 1.96 should be equal to, if this is the value of x, what is the value of z? The value of z will be 1.50 minus d minus mu, that is 1.50 by sigma. So sigma is 0.2. So this is basically minus d by 0.2. So what we get? We get d is equal to or we can also consider that this minus d is equal to 0.2 into 1.96. So that value will be like 0.392. Okay, so in case of this, they are asking what is the value of d. So d, actually, this is there is a small confusion. I hope you have understood the point. The point is that this specification, if z is equal to 1.50 minus 0.392, because that is what I am or to avoid, let me let me do one more to avoid this confusion, because some of you may get confused. So what I am using, this term 1.50 plus d, and I am comparing it with 1.96, because the mistake that I made here, I don't know whether you remember understood this mistake here. If I am comparing it with the minus 1.96, this value I have to take minus 1.96. So let me now write it. So d is equal to minus 1.96, this minus and this minus will be gone, so this minus you can remove, and 0.2. So this will give you 0.392. There was a small confusion because I was taking one of the values and not considering the minus sign. You could have also done this. You could have done this, that 1.50 plus d, if this is the value of x, this is the value of z. So you could have compared that 1.96 is equal to 1.50 plus d minus 1.50 by sigma, that is 0.2. So in that case also you will get the value of d, that is 0.392. Okay. So I think in this video I have talked about normal distribution, its important properties, and some interesting problems. Next video I will talk about normal approximation to binomial distribution and how to calculate the moment generating function of the normal distribution. In case if you are new to the channel, subscribe it, and in case if you are already watching the videos, like and share. That's all from my side. Thanks for watching. Have a great day.